Time and space are like a fabric, like rubber, like a trampoline net. Now, imagine turning this trampoline net into a pretzel, allowing yourself to go backwards in time. Have you ever questioned what's truly out there in the cosmos? What mind-blowing mysteries the universe might be concealing from us? Well, you're in for a ride. We have a revelation so colossal it's about to rewrite everything we thought we knew about the universe. Brace yourself as renowned American physicist Michio Kaku unveils a discovery that's nothing short of revolutionary, brought to light by none other than the legendary James Webb Space Telescope, which may have proven that time does not exist. Ready to dive into a space-time riddle that's going to turn your world upside down? The James Webb Space Telescope is essentially the Hubble Space Telescope's bigger, cooler sibling. Launched on Christmas Day 2021, this telescope has taken up residence in space, illuminating secrets from the universe's darkest and most distant corners. It's like the ultimate time machine, equipped with super powerful infrared instruments that make it perfect for peeping into the past. How, you ask? Its unprecedented resolution and sensitivity allow it to detect incredibly old and faint objects that even Hubble couldn't glimpse. We're talking about distant galaxies and celestial bodies from the early universe, those elusive entities that have been playing an epic cosmic game of hide and seek with us. In essence, James Webb is helping us piece together the universe's grand, star-studded jigsaw puzzle, one infrared image at a time. Now imagine you're at an art gallery, strolling past grand pictures captured by the James Webb Space Telescope, also known as JWST. The imagery is breathtaking, with distant galaxies shimmering across the cosmic canvas. Yet, among the astronomers and cosmologists, you notice shock and disbelief. There's a sense of turmoil, almost as if they're staring at a Picasso, painting in a room full of realists. The common phrase you hear is, "This is unexpected." So, what's the fuss all about? What has rattled the very foundation of their understanding of the cosmos? Although official papers remain tight-lipped about it, the real issue lies with a theory they hold dear: the Big Bang hypothesis. This is the idea that our universe kicked off in a massive explosion about 14 billion years ago and has been expanding like a giant balloon ever since. This theory has been the cornerstone of cosmological understanding for years. And now the new images from JWST seem to question its validity, sending shockwaves through the scientific community. You can almost hear Allison Kirkpatrick, a seasoned astronomer from the University of Kansas, tossing and turning in her bed, questioning her life's work. Why is everyone so surprised? Well, the galaxies captured by JWST aren't behaving as they should, according to the Big Bang hypothesis. They're too small, too smooth, too old, and there are far too many of them. Let's simplify the too small conundrum. If you imagine the universe as an expanding balloon, galaxies shouldn't look smaller as they move away from us. After a certain point, they should start looking bigger because their light supposedly left them when they were closer. It's a weird but essential twist in the expanding universe concept. Yet, the images from JWST show galaxies that are about the same size as the ones near us. It's like expecting distant friends to appear as tiny dots on the horizon. But instead, they're right next to you, just as large as life. Interestingly, the galaxies JWST shows appear smaller than we'd expect, even those that shine brighter and pack more mass than our own Milky Way. These pictures reveal galaxies that seem 2 to 3 times smaller than the ones seen through the Hubble Space Telescope, HST, despite their greater luminosity and mass. Additionally, these galaxies have significantly higher redshifts, meaning they're supposedly moving away from us at faster speeds. If you're thinking, well, that's odd, you'd be right, especially if you're operating under the assumption that we live in an ever-expanding universe. In 2014, some scientists had already pointed out this inconsistency. They analyzed HST images and found that galaxies with redshifts up to 5 seemed to match what you'd expect in a non-expanding, typical space. It was anticipated that JWST would continue this trend, and it has even for galaxies with redshifts as high as 12. In simpler words, the JWST images show galaxies that appear the same size as those close to us, as if the universe isn't expanding and redshift is merely a function of distance. But if we still cling to the Big Bang Theory and its expanding universe concept, we're left with a perplexing conclusion. These distant galaxies must be unimaginably small to counterbalance the supposed optical illusion created by an expanding universe. It's a bit like imagining a grain of sand with the brightness of a spotlight. Take, for instance, a galaxy named Gigahertz 2, spotted by JWST. It's far brighter than the Milky Way, but is calculated to be only 300 light-years in radius. Compare that to the Milky Way's 50,000 light-year radius. Its brightness per unit area would be 600 times that of the brightest galaxy in our local universe. Not only that, but its density, and that of several other new galaxies, would be tens of thousands of times higher than the galaxies we see around us today. When you consider these tiny and smooth galaxies, the notion of an expanding universe, and by extension, the Big Bang Theory, starts to crumble. That's why these findings are causing quite a stir among astronomers and cosmologists. Over the years, Hubble Space Telescope images have given scientists a hard time. The pictures suggest the existence of many galaxies, dense and powerful, much like Mighty Mouse from old cartoons. These galaxies are a challenging puzzle, and with the new James Webb Space Telescope, things have only gotten trickier. To make sense of these peculiarly tiny galaxies, theorists have proposed an idea. It's as if you're playing with a tiny toy car, a magical one, which despite being only a centimeter long, weighs as much as an actual SUV. They suggest that these microgalaxies smashed into each other over billions of years, merging to form the full-size galaxies we see today, like toy cars colliding and growing up to be real SUVs. But here's the twist. JWST has taken a close look at these galaxies and found no signs of such cosmic collisions. You'd expect these galaxies to show some signs of damage, right? Maybe look a bit scrambled or mangled like a car after a fender bender. But that's not what we see. Instead, JWST reveals galaxies that are smooth, neat spirals, just like the ones nearby. There's an overwhelming lack of galactic fender benders. In fact, one study, titled Panic, highlights that there are 10 times more of these pristine spiral galaxies than theorists have predicted. It's akin to finding a busy highway full of speeding cars but no accidents. This is a significant blow to the collision theory. With no signs of galactic mergers, the idea that these tiny galaxies somehow expanded into their grander counterparts falls apart. If they didn't grow in size, it means they weren't small to begin with. Consequently, the optical illusion expected from an expanding universe doesn't seem to be there. Without this illusion, the concept of expansion loses ground, hence the growing unease among Big Bang enthusiasts. The appearance of these small and smooth galaxies suggests that the universe may not be expanding. And if it isn't, the Big Bang Theory takes a major hit. There's another aspect to consider: the age of stars. The Big Bang Theory suggests that everything came into existence following the big explosion. However, if these galaxies existed before that, then it would mean the Big Bang didn't happen. This could be a game changer for our understanding of the universe's origins. Consider the James Webb Space Telescope as a time machine. In the words of Michio Kaku, it's able to peer billions of years back into the cosmos, capturing images that shed light on the universe's origins. This incredible device isn't snapping photos in our familiar visual spectrum. Instead, it's focused on the infrared, revealing colors of galaxies so distant we could never observe them with the naked eye. Now, here's the fascinating part. These colors aren't just beautiful. They're telling a story about the age of the stars in these galaxies. Young, fiery stars blaze a vivid blue, while their older, cooler counterparts, similar to our sun, glow in hues of yellow and red. By examining these colors, astronomers can estimate the age of star populations in these distant galaxies. According to the Big Bang Theory, the galaxies farthest away in the JWST images represent a cosmic snapshot from around 400 to 500 million years after the universe's birth. However, some of these galaxies appear to house stars that are over 1 million years old. Now, if you've been following the Big Bang Theory, you know that's a significant issue because nothing should be older than the Big Bang itself. Another expectation, if the Big Bang Theory is correct, is that as we gaze farther into space, which means looking further back in time, we should see fewer and fewer galaxies until we reach a point where there are none, a cosmic dark age. However, it seems to be a different story. It appears that galaxies as massive as the Milky Way were already quite common even a few 100 million years after the supposed Big Bang. The new images indicate that there are at least 100,000 times more galaxies than predicted at high redshifts, more than 10. So the question arises, how could so many large galaxies form in such a short time? The answer is they probably couldn't, at least not under the constraints of the Big Bang theory. That's why these discoveries are challenging the foundation of our understanding of the universe. On top of that, there's a deeper philosophical quandary, the nature of time itself. Modern physics operates on the assumption that time exists as a fundamental concept, deeply ingrained in our understanding of the universe and intertwined with Einstein's theories of relativity and countless scientific principles. But what if time, as we understand it, doesn't really exist? This hypothesis, though radical, isn't entirely new. Some theoretical physicists have speculated that time might not be a fundamental aspect of reality, proposing that our perception of time could be an emergent property or even an illusion. In the context of the universe's origins, this could mean that our understanding of events unfolding in a sequence, with a Big Bang as the starting point, might be fundamentally flawed. If time doesn't exist in the way we perceive it, then the concept of a beginning like the Big Bang becomes meaningless. This could radically alter our understanding of the cosmos, requiring a new framework that doesn't rely on time as a basic component. Instead, the universe might be better understood through a lens that views space-time as a whole, without a sequential start or end. This paradigm shift could potentially address some of the perplexing observations made by the JWST, such as the existence of mature galaxies in what we previously thought was the early universe. If time is not a fundamental property, then these galaxies could be older than the Big Bang without contradicting the laws of physics. Essentially, without the constraint of time, the universe might not have a singular beginning at all, suggesting a more complex and intertwined cosmic tapestry. In this new model, the cosmos might exist in a state where past, present, and future are not linear, but coexist in a manner beyond our current comprehension. This would have profound implications not only for cosmology, but also for our understanding of existence itself, potentially leading to groundbreaking discoveries about the nature of reality. The debate between the Big Bang and the steady-state theories represents two fundamentally different views on the universe's nature. The Big Bang theory posits a universe with a definite beginning and a history of continuous expansion. On the other hand, the steady-state theory suggests that the universe has no beginning or end, with a constant average density and ongoing matter creation to fill in the gaps left by expansion. To sum it up, the James Webb Space Telescope is not just offering a new lens through which we can observe the cosmos. It's also presenting data that challenges our long-held assumptions about the universe's history. These observations might indicate that the Big Bang theory, as it currently stands, is not entirely accurate. Instead, the universe might be eternal, without a distinct beginning or end. This doesn't necessarily mean that all our understanding is wrong, but it does imply that there are deeper, more complex mechanisms at play that we have yet to fully comprehend. It's an exciting time for astronomy and cosmology as we stand on the brink of potentially groundbreaking discoveries that could reshape our understanding of the universe.